Thanks for joining. I'm Prashant. I am joining from Nihilent Limited. I work as the lead technology advocate in the Microsoft practice here. And what we do is we are a global consulting and a solutions integration company. And we work with our customers in India, in the US, UK, Africa, and Australia. And we provide services in the area of data management, including analytics, reporting, machine learning, cognitive analytics, IoT, and blockchain. And we are a Microsoft Gold partner. Talking about our services very quickly, all our services are inspired by our core design thinking philosophy. And there are four main pillars of our integrated services. And business intelligence and advanced analytics is one of those pillars. So the topic of this webinar is really inspired by the work that we have been doing in this area. So having covered what I do and what my organization does, we'll get into the topic of this particular webinar. So what are we going to cover today? So I'm going to talk about the main technology trends and the business drivers that are driving big data programs. And then we will also talk about how does a big data program looks like and what does it constitute. And then why is it super important to know your data really, before you get onto the journey of big data implementation. After that, we will dive into some common architecture practices. And then we will also see how Microsoft Azure can be used in realizing those patterns. And last of all, we will talk about some key considerations that Nihilent has been endorsing over the years. Let's start with a very big picture, right, of a 10,000 feet view. And what we'll see is there are three major trends that are shaping our immediate future. The first is very obvious, right? There is an exponential growth of data. I mean, it is so natural because there are 26 billion devices today in the world that are generating so much of data every day. And in a few years, we are probably going to have 175 zettabytes of data with us. The second trend is the rapid adoption of cloud across all the organizations. And this, people were very skeptical a couple of years back, but today a lot of the organizations are on cloud already. And then the third is the rapid improvements that are happening in artificial intelligence. And therefore, business is adopting artificial intelligence very quickly. So these trends, right, if you see the data explosion, the adoption of cloud and the artificial intelligence, these are all enabling a lot of our organizations to create new business models and to enhance the existing ones. So for example, my customers are using these technologies to improve things like their processes, they are improving their customer experiences, they're achieving their regulatory compliance needs, creating new products, reducing costs, improving marketing, and also managing risk. And by doing this, they are outperforming a lot of others in the industry. And Nihilent is partnering with them to build their big data platforms. So having seen what the technology advancements and what the business drivers are, let's get a look at what exactly a big data program looks like. Now, many of you might have already seen this definition of big data, right? This is a classical definition of big data where we say, there are three V's. It is characterized by these three V's. We always say big data is like it has a large data volume, it has a variety of data formats, and it has high velocity, near real-time data, and so on. But how does it translate into reality, right? So when we look at a big data program, first thing that will strike you that it is going to be a multi-platform architecture. And there are going to be multiple things in it. There is going to be a data warehouse. There is going to be a data lake probably. You might have some Hadoop clusters already, which you might want to coexist those clusters with your data warehouse and data lake. And obviously there is going to be a data integration layer to move components. And then in some cases, you might even want to use data virtualization, to run your remote queries. Now, naturally, if it is going to be a multi-platform architecture, then obviously we're going to require some kind of a governance model. And that governance model is probably going to be assisted by master data management and data catalog and search. What we are also going to have, obviously, because this is a big data platform, we're going to have lots of advanced analytics, right? We are going to have a data science team doing their research work. Then there's going to be a lot of machine learning and obviously business intelligence and reporting. So in a nutshell, what happens is when we look at the big data program, we see that it is going to have many components, it is going to have many layers, and it is going to have many technologies. So you would start wondering, if it is going to have so many layers and technologies, then how should I start, right? So how would I get to the right, how would I choose the right data architecture? And how would I get to choosing the right data stores? What should be my data integration approach? And what is going to be that effort that I'm going to need to do data cleaning? So in order to answer these questions, what I have learned is understanding our data is very important. Understanding the data that my organization is generating and that the data that my organization is going to rely on, understanding that is very important. So things like, I would ask myself what type of data is going to be acquired and stored in my big data platform. Is it going to be streaming data or only batch data or both? What is the volume of that data? How much of that data is raw data and how much of it is going to be usable data? And do I need to store both usable data as well as the raw data? And then, even I would go further and see whether I need to store this data in a centralized location, or does my business mandate me to have a multi-platform based architecture? And then I would also like to see what are the data privacy and the regulatory needs of my industry or my particular company. Then what are my operational SLAs? Then what is the quality of my data? How much of cleaning is going to be required before it can be made useful? And even my source systems, right? Do I have all the appropriate licenses with me to be able to extract the data from the sources? So there is a whole gamut of things that I would like to know before I can get onto my big data journey. And obviously, you can see there is going to be a lot of effort into it. But the one thing that we have seen is once you put that effort and you know the data and you get a handle on it, I think that's the best way to start, because then you will be able to take a look at all the suitable architectures that you might want to use. And that's where we can start this journey of a big data implementation. So having looked at this, let's get into, let's think about what kind of architecture, once I get a hold of my data, what kind of an architecture do I want to implement? And that's where we come into this area of looking at, there are some common architecture patterns already there in the big data world, right? People have already tried this, tested it. Nihilent, we have been proposing one of these architectures on most of our projects. So we will get through this discussion very quickly. And on this slide, I would request you to please bear with me, because this is a little bit of theory over here. And I understand theory can sometimes become a little bit monologue, but I promise you, after we get past this slide, they will definitely get into some exciting discussions of how these architectures, right, these patterns, how they will look on Microsoft Azure, and what from Microsoft Azure you can use to implement this pattern. So let's get on these patterns as well. The first one is a polyglot pattern. And here the idea is that, instead of I having a centralized data store, I might want to have multiple data technologies to store my data, and for obvious reasons, in the sense that different technologies are good at handling different types of data. So I might want to get them processed efficiently. And therefore, I might be in a situation where I might have to have more than one technology, a data technology and a data store. Now that could be because of the best fit architecture that I want to get into, or it could also be because of some regulations or some constraints that my business have, that I have to distribute my data and I cannot really bring it into one central location. So polyglot essentially what says is you will have data in different database technologies, and then for the analysis and for the reporting purpose, you have to aggregate all these different analysis into one place. So there is some work needed to do the analysis and the analytics and to serve that analysis to your end users. And then obviously from an IT perspective, it increases some complexity, right? Because then you have to think about the IT operations, the synchronization across all these different sources. You have to think about how are you going to test these different sources and the analytics that is coming out of it. So there are both the pros and cons of using Polyglot. The next pattern is the Lambda pattern, right? And the Lambda pattern emerged because this layer that you see over here, the batch layer, right? So this batch layer is typically our standard data warehouse batch process, right? If people who have worked on data warehouse, they know that, it's a standard process. We do ETL. I mean, we first fetch the data, do ETL, clean it up, transform it. It goes into data warehouse, and then it is served to the downstream applications. Now that takes some time, right? I mean, it might take even 1 or 2 days. We run nightly jobs and so on. Now, because of the revolution in IoT and the social media applications giving you streaming data all the time, a lot of the organizations are going to need this speed layer as well, where there's a streaming data coming in continuously. So how do you give a holistic view to your end users, the analytics? How do you give that view, a combined view of the analytics? And that's where Lambda came into picture, right? So Lambda had 3 layers, right? The one is a speed layer, which is this one, the speed layer, which will handle your streaming input. Then your batch layer, which is your traditional data warehouse flow. And then finally the data serving layer, which is going to basically combine and give you a holistic view of analytics from both these layers. Now that is fantastic, right? Because in one system, you're getting a view from everything. But then what happens is you end up duplicating the core, right? Or your logic. So your logic might get duplicated both in the batch layer and the speed layer. And therefore, then some organizations came up with this idea of Kappa pattern, this one. Now Kappa tries to mitigate the code duplication of Lambda, right? It tries to mitigate that problem by saying that, look, we will have only one single data pipeline, right? Only one single process for processing the data. So that's very good. Everybody will like this approach. But then what happens is, what it also implies is that you have to have a single data source, right? A single data stream, in fact, which can supply all your data. So what it means is everything, all the data that you have in your organization, everything of that has to be written to this data stream, first of all, a single data stream, so that it gets processed in that single data pipeline. So the advantage is, yes, okay, you avoid all the duplication of work, but then there is a lot of upfront work that you have to do in terms of writing all your structured, unstructured data to the single data stream, right? So, and then obviously you will need a lot of infrastructure to do that as well, and you will have to manage that infrastructure on your own. So these are the 3 patterns that are in existence. Now there are a lot of variations available. There are a lot of examples, industry-wise examples available. In many places, in fact, on Azure websites also, you can see a lot of recommendations of the variations of these particular platforms, of these patterns. So in my experience, we have been proposing Lambda pattern in most projects because it is very helpful in combining the streaming layer and the batch layer and giving a very holistic view. It's very practical. And we have done multiple successful projects using the Lambda pattern. The case in point is one of our customers in the US, MNO McGinn, where we have implemented this pattern. This particular customer, they're the #1 parking solutions provider in the world. So there was a lot of theory in this slide. So thanks for bearing with me. And as I promised, we will now get into seeing the practical approaches of how Lambda or how Polyglot looks on Azure platform, or what are the things in Azure platform that we can use to implement Lambda and Polyglot. So here we go. Here's a architecture or a diagram. It's a representative diagram of Polyglot on Azure. So on the left, I have my data sources, structured and unstructured, and then I have a data ingestion layer. Then I have data storage, where we are using Data Lake over here for data storage. Then I have a processing layer, right? And from processing layer, then I would get into the Azure SQL data warehouse. Now, in most cases, that would suffice, just getting data in the Azure SQL data warehouse. But then because of some certain requirements within my business or my company, I would also, in this particular case, I had to get the profile database into HBase because it was going to be further processed later in some other system. And then also we had a ODS layer in this particular company. And therefore we had to get some data in a traditional relational model of SQL Server. And obviously on the top here, you see the in-streaming data, right? After it was processed by Azure Stream Analytics, we had to store it in a JSON format in Cosmos DB. So we ended up having different technologies to basically store different types of data. So that's where we got into Polyglot. Now this is not the only way where you might get into Polyglot. You could also get into Polyglot on the data sources side over here. I had a customer who had a constraint, because of some regulatory constraints, they couldn't move their, payroll data and the time and invoicing data out of a particular country. And therefore we had to do analysis locally over there, right? So therefore we ended up having a separate databases in different countries. So that could also be one of the reasons why you could get into this kind of a pattern, the polyglot pattern. So moving on, the next one that I would also show you is how does a Lambda look like on Azure, right? So this is again one example. This is, I want to stress that this is not the only way you can do Lambda, but this is just an example. There are many variations, and I will show you some of the other options that are there on Azure. And I like the components that Azure offers. There are big data services, there are components, and there are many options on Azure so that you can implement this as per your own specific requirements. Let's talk about this, right? Lambda on Azure. You see the red line in between. So, on the top is something that we call the speed layer. And then below the red line is something we call the batch layer, right? So the batch layer, most of us will be familiar with that, right? It's a typical layer of, getting the data, doing ETL, putting it into either you would store it in a staging area, let's say in Azure Data Lake, and then you would put it into Azure Data Warehouse after processing it, and it could be consumed by your applications, the reporting applications like Power BI and so on. So other than that, then you have this streaming layer on the top, right? So events coming through Azure Event Hub, again being processed, stored in Cosmos DB. And this example shows that, yes, I can have both the systems, and I can get data and analytics from both streaming data and batch data. And then I have combined here, this is a serving layer basically, where I will see which data, which reports I want to get from my speed layer and which are the ones that I would combine it with the batch layer. So this is how it would look. On the next slide, I will show there are various options. As I said, this is one particular pattern. On Azure, we have multiple options for each of these components, right? So even if I think about data storage, I have different options. Here I'm using data lake, but I can use some other things to store the data. Here I'm using Azure Databricks over here for processing, but there are other technologies in Azure which I can use as per my particular scenario and requirements. So I will get into first looking at what are the options for the batch layer, right? The bottom layer over here, where we are talking about, the batch processing. So if you look at the options, particularly for data storage, prep and train, and the serving storage, as I said, right, in my earlier slide, we were using Azure Data Lake, but then if I don't want to use it, if my requirements are a bit different, I can use blob storage as well over here, and then I can use SQL Server database also to store that. So then as I was saying, right, so processing again, you will have multiple options, right? You could use USQL from Data Lake Analytics, Azure Data Lake Analytics uses USQL. Or if you already have something on Hadoop, right, and you want to use your existing programs, the investments that you have done, you could do that. You could use it on Azure, right, because we have HDInsight on Azure, right? So you could still use all your current assets as well. On the serving front, obviously SQL Server, Azure SQL data warehouse is there, but then other than that, there are other options for you to use them on Azure. So multiple options available in Azure for the batch layer. Similarly, for the speed layer, right, we have more options again, right? So you could have Event Hub over here and the data coming from that. You could use Azure Stream Analytics to process it and then store it in Cosmos DB. So the point here was that you really need to see what you need, what's your workload, and accordingly you could choose any of these components. I want to spend a little bit of time talking about two key technologies here, right? One is the Azure SQL Data Warehouse, and then also I will spend a minute or so on the Azure Data Lake as well. Now, a lot of us, if we have worked on Microsoft SQL Server, we will find some familiarity if we start working on Azure SQL Data Warehouse. In terms of both are relational databases, Azure SQL Data Warehouse is also relational. You will find similarities in terms of kind of queries you write and so on. But then what we need to understand is that Azure SQL Data Warehouse is a cloud, it's a fully managed system for processing large amount of data. And the way it is designed is, first is, the storage and compute both are decoupled, if you see over here, right? So the compute nodes are decoupled from storage. So what it means is that you can scale compute if you want, right? You can scale it out. You can increase the nodes, decrease the nodes, and then the billing that happens to you is also separate, right? So you will be billed separately for the compute and billed separately for the storage, and that's a great thing because then you can increase parallelism by just scaling out the compute nodes if that's what you require for a certain hours of the day. The other aspect that one definitely needs to take into account that this architecture is different, right? So it's a massively parallel processing engine. That's what it has. And it is completely different from the symmetric multiprocessing that happens on a normal SQL Server data warehouse. So because of these changes or the architectural changes behind the hood, how does Azure SQL data warehouse works, it is important that you understand that your data modeling strategies are going to be different. If you plan to implement a data warehouse on Azure SQL data warehouse, then you would have to think about your data modeling strategies because of the architectural changes that you see here. And then not only that, you would also have to think about the partitioning strategy and how are you going to distribute your tables across the distributions that are available in Azure SQL data warehouse. How are you going to use the in-memory structure? So all these things become important. And if you have somebody in-house, an expert in-house, that would be great. Otherwise, I would recommend to have some expertise to come in and work with you to do this, the data modeling and the partitioning and using things like clustered column index and so on. Right. So that was about the Azure SQL data warehouse. The next, I would go on and talk about a little bit about Azure Data Lake. I'm not going to talk a lot in depth, but wanted to highlight a few things. Now, Azure Data Lake is a hyperscale repository. There is no doubt about it, right? But I think the key value of it comes from the fact that businesses and your customers will be able to store any type of data that comes in its native format, and you can store it as it arrives in a data lake, right? And the value to the business is that they don't have to worry about using it immediately, right? The data comes in, you store it as it is in its native format. The business might want to analyze that data late. They might want to analyze it immediately or later, maybe after a month or after 6 months. And that's the value that Data Lake gives. And all the other components most of the components in Azure, like HDInsight, Azure SQL Data Warehouse, they all have connectors to the data lake. So it becomes very easy for you to connect to your data in data lake, start doing your analysis and so on. The next thing I would like to talk about is, there are many features in Azure Data Lake Storage, especially in Gen 2, but a few things I would like to highlight here. The one thing is, since Azure Data Lake is an open, it doesn't constrain you in how you store the data, and therefore it becomes very imperative for us to plan that out. So a zoning strategy becomes important, right? How am I going to get, the data is going to come in every day, every month into data lake. What is going to be my strategy to prevent it becoming a big mess or a swarm? So what do I want to do that? I need a certain disciplined approach to store the data. And therefore, I'm going to have something like a landing zone to get the data that comes in. Then I might have a staging zone as well after doing some validation to see whether those files are okay, they're not corrupted, then I might move them into staging. And I might also want to have a curated zone as well in a data lake where I do certain changes to the files and then move them into curated zone. So all these things are facilitated by the fact that there are things like hierarchical namespace in data lake, or even things like file level security, which becomes very important for me to say, what kind of role-based access can be given to different people. So that's a very good set of features that are available. The other area that is very useful is the tiered storage. So the tiered storage was available in the blob storage earlier, and now it's there available in data lake storage Gen 2 as well. And I think it is going to be very useful for lowering your total cost of ownership, because you might come across data you think would be very infrequently used. It might be a good place to store that in a cool storage, right? Because then cool storage will cost you less, but you have to remember that the SLA for a cool storage would also be less. But if you're okay to live with that, then that's a great feature to use. And of course, archive storage as well, right? So if you have certain things that you want to archive for 6 months or something like that before you delete it or remove it, you could do that as well. So good features for you to manage your data within data lake and try to see how you can balance your total cost of ownership with the performance that you want to get out of it. So with that, I think we took a quick look at many things, right? We saw what a big data program looks like. It has many layers, many technologies. We saw why it is important to know your data first. We looked at some patterns, and then we looked at how those architecture patterns can be implemented on Azure. And then I think this is we'll get to this, the last section. What are the things that you should keep in your mind, right, when you start your implementation or when you start rolling out your big data programs. So the first one that I would like to talk about is the relationship between data lake and data warehouse. And many of you will say, Prashant, this is so obvious, right? They both look very complementary. And I would agree with you completely. But imagine the number of times this discussion comes up in many places. The question I often hear is, why would we need a data warehouse if we are going to implement a data lake? I usually like to step back and talk about, first of all, the nature of these two technologies, right? So what does a data warehouse store, right? We all know it stores transformed data structured in a relational database. Whereas Azure Data Lake, we are looking at raw data completely, right? And we don't even know what comes in an Azure Data Lake, how it is going to be used in the future. We are just keeping it there because we know at some point of time, the data scientist in my company, my business is going to make use of that raw data, but that is going to happen later, maybe, right? So there's no structure to the what I store in data lake other than the zoning, the strategies that I might implement in terms of governance. And therefore, acquiring data for a data warehouse front needs a lot of efforts, right? You know that, right? Because you must have done all this earlier in the sense that you have to design the schema, do transformation, put the data there. In a data lake, obviously, the effort to acquire data is very less. And exactly the opposite happens when you try to retrieve the data from a data warehouse, right? Because your data is already in a ready state, transformed, cleaned, trusted data. There is so much of less effort. You probably just pull it out and give it to your reporting applications. And on the other hand, because in the data lake, your data is raw, you are going to need a lot of efforts to retrieve the data from data lake. So there's a complementary nature. Each has a role to play in a big data program. That's why I thought it's worthwhile discussing this point. The next thing is, you remember earlier in this presentation, I was talking about why it is important to know your data in the first place. I think equally important is to know how your big data is going to be used. Who are your users? When I say users, what I mean is how are they going to use your data? Are they going to use it for self-service BI, or are there some people who want to use it for operational BI? Are there expectations that your big data platform will provide some business alerts or even IT alerts? What kind of dashboard are your business people are going to use? What's the complexity level of those dashboards? And then what's the data science community in your organization? What are they going to do? How are they going to use machine learning? What's the concurrency? How many of them are there? The reason I'm putting these questions is all these puts a lot of load on your big data components. And the key area, if you want to succeed over here, right, if you want to manage all these workloads, all these queries that are coming to you, the key area is to make sure that somebody is optimizing all these queries, right? Because you want to keep the memory footprint as minimum as possible. And query optimization, wherever it comes, it could be coming from your Power BI requests or dashboards, or even a SQL workbench. Query optimization is the key. And while I'm on this topic, let me quickly talk about the importance of semantic models, and especially about the SQL Server analysis services. It provides a fabulous tabular model. But then there could be cases where you have complex dashboards and the performance requirement on those dashboards is very high, or you might have many concurrent users using those dashboards. In that case, I think SQL Server analysis services cubes, they still have a lot of value in a big data program. Then the next I want to talk about is the high frequency data. Won't spend much time on this. Essentially, what we are talking about here is you see your traditional normal batch processing that happens. The data would flow through your Azure SQL data warehouse. Typically, it would take maybe a day or so, right? You would probably have nightly jobs to process the data. But there will be situations where the business might want to see the data more frequently, maybe every hour, right, or maybe every 2 hours. For example, if they are running a ad campaign and they want to see how many people are registering in response to that ad campaign, or what's the growth in the sales happening, right? So they wouldn't want to wait for the data to come through data warehouse and see the reports the next day. So they would want to see it immediately. So in that case, you could have this different path for some priority data. So it could be high frequency data. You could have a separate data mart to do that. Now, obviously, that is probably not very accurate data, because you are actually bypassing your transformation processes. But since business values this data, even if it is inaccurate, even if they want to see it quickly, that's why you're providing it. So, you probably want to keep it as a staging area, like with a history of only 24 hours, with a higher frequency of passing that data to your end, to your reporting applications. And then one area I also wanted to talk about was the data ingestion, right? The data movement from place to place. Traditionally we have been using SQL Server integration services. It was a great tool, to do in-flight transformation. The library was fantastic. It provided a lot of functions. Now, if you go onto cloud, you have something called as Azure Data Factory, and it is very good for doing large data movements. And what I like is the orchestration that it provides to me, right? So I can actually manage complex data pipelines, data movements. That's a very nice feature of ADF. And obviously, you get all the advantages of the cloud service if you are using Azure Data Factory. And it is designed to be more like an ELT tool. You first load the data and then transform. So it's more of an ELT rather than ETL. But it's worth looking at Azure Data Factory as well. And then one area that I want to talk about was the data transfer strategy. You could have one-time data transfer you might have to do when you start the program, the big data program. And then you will have the ongoing everyday data that also needs to be transferred to the cloud, right? From your on-premise systems to the Azure cloud. Now there are so many different tools available, right? There are tools available to do transfer over the network. And then there are shippable devices also that Microsoft provides. So you really need to see your data and then come up with a strategy, what you need in order to move your data to the cloud. And it will all depend on what is the network bandwidth that's available to you and what is the size of your data. So, initially the one-time load, if it is very large, you might want to look at the Azure import-export service. There are data box services also available, but I think that the data box is still not available in India. But I wanted to mention it over here so that you are aware that this might be available to India geography as well. But the whole picture is that there are many options available, and you really need to think about your data transfer strategy to the cloud as well. And this is the last point that I wanted to highlight. And I think this one gets a little bit neglected in a big data program. What I've seen is I always think that big data is a complex program. We have seen that in the past slides. And it is an enterprise asset. And I believe that we should apply the enterprise architecture perspectives to this program. I think the big data architecture that you prepare, it should align with your business architecture. And you should try to answer the data security and the quality requirements of your enterprise upfront so that you don't get into rework at a later phases. So the performance requirements, the scalability requirements, it is better to evaluate those requirements upfront and answer them as early as possible in your journey. So in summary, as I said, big data is a complex program, but it is business drivers and the technology trends are really driving it, pushing it very fast. And Microsoft Azure provides several options for you to, do data storage, processing, analytics, and so on. But in the end, there are many factors that are going to drive the choice, of your architecture and the tools. And Nihilent has a specialized data and analytics service line. We do end-to-end big data projects. We have successfully implemented big data engineering work. We have an expert data science team. We have also built some accelerators for some common analytic use cases. And we are a Microsoft go-to partner. So with that, this is the end of my presentation. If you have questions later, you can send those to me on the email as well. Thank you.